Welcome to part 3 of the Digger tutorial series. In the last lesson we put together a branched flow that performed different processing to different data. In this lesson we will discuss some of the data concepts and terminology relating to that flow. The smallest data element that Digger deals with is the seismic trace. However, most of the interesting ways of viewing and filtering seismic data require that these individual traces be collected into groups referred to as ensembles. These should be familiar concepts for anybody with a background in seismic processing, as should be the idea of trace headers, which is the data associated with each trace. These named values can be viewed in Splot by holding Ctrl and Shift while moving the mouse in the data window. Digger flows work by passing ensembles from module to module. Some special modules allow for multipath flows. In Lesson 2, the modules fork and join were introduced for performing conditional processing. We will now take a closer look at the way that data moves in a fork-join flow. Firstly, we will run a segin with only a Splot attached. The segin parameters specify how the segway file will be split into ensembles. When the ensemble division method is set to key, it will look for changes in the specified trace header, FFID in this case, and produce a new ensemble every time it sees a change. We have also specified that we would like to read only one ensemble. Let's take a look at what this single ensemble looks like with a Splot. After running the flow, we can see that 96 traces in one ensemble were emitted from segin. Now we will run through the branching part of the flow using the same segin parameters. The condition in fork now states that all traces with a source to receiver offset, or dist, less than 500 meters are to go to the left. The log file shows that 2 ensembles were emitted from fork, one for each branch. The 2 copies of the module scale share the total of 96 traces. Notice that the order of the traces has been disturbed due to the branching, as join simply concatenates what it receives in the order that it receives it. We can re-establish the original order of traces in this case by requesting join sort the traces by header chan. Now let's remove the limit of the number of ensembles in segin. Well, as it turns out, this is quite a small file, so only 10 ensembles are read. Again, examining the log reveals the way that the data has flowed through the modules. The Splot window allows us to navigate through each of these ensembles. Finally, we will look at one more flow control module called Buffer. As the name suggests, this module can be used for collecting up a sequence of incoming modules and concatenating them together. That concludes this lesson on the data flow within Digger. Next lesson we'll go into some of the features of Splot.